Hello, welcome to another screencast of dealing with quadratics. This one specifically is dealing with solving quadratics by completing the square. This is a more advanced example, so if you don't have any prior knowledge dealing with completing the square, some of the more simple examples, or what are some of the techniques that this is based on, then this probably isn't the video for you, and you'd want to find something that could help you with more of the basics. This one is a more advanced one because it has a leading coefficient, which happens to be 4 in this case. So that's going to complicate things a little bit. So to start out with, we're going to assume that this minus 5 out at the end, the constant, is not what we need in terms of having a perfect trinomial square over here. We could check that by trying to factor this. Sometimes it's just not worth the time. You just go ahead and say, I think I'll get rid of the minus 5 by adding 5 to both sides of this equation, so that I'm left with 4x squared plus 40x equals 5. Now, this is where we'd normally work on completing the square. I usually call it the fill in the blank step. But before we can get to that, we have to deal with this lead coefficient of 4. And what we're going to do is factor it out of this binomial over here. Now, thankfully, in this example, 4 is a factor of both terms. But even if it wasn't, we would still have to factor it out. So factoring out is division. So 4 divided by 4 is 1. 1x squared can be written just as x squared. 40 divided by 4 is 10. So we get 10x. And this still equals 5. Okay, now we can go ahead and work on the fill in the blank step, the completing the square step. So inside the parentheses, I'm going to put a blank. And over on the right side of the equation, I'm going to put a blank, because I'm going to be adding something to both sides of the equation. So first of all, over in here with the quadratic, to build a perfect trinomial square, we use a little shortcut where we take the b value, we divide it by 2, and then we square it. And that will guarantee that this trinomial is a perfect square. So b is 10, divided by 2 is 5. 5 squared is 25. Now this is one of the most difficult steps to remember, and it's often forgotten as a result. Now I just added 25 to the left side of the equation, or so I think, but I didn't really add 25. I added 25 times 4, because there's this 4 that's out in front of this set of parentheses. So whatever's inside of here is really being multiplied by 4, meaning to keep this equation balanced, I need to add 100 to the other side, which is 4 times 25. Okay, from here, we now factor this quadratic, and two numbers that multiply together to give you 25, but add together to give you 10 are 5 and 5. Over on the right side, we'll just simplify that by adding and getting 105. Now we're going to use the power of 2 to simplify the right side. Into x, 4 times x plus 5 squared equals 105. And from here we are going to just solve, trying to get x by itself. Dividing by 4 would be my first step to leave me with x plus 5 squared equals, and at this point you can make some decisions on, do you want to leave this as a fraction or as a decimal? Can you reduce it? I'm going to go ahead and leave it as 105 fourths. Okay, so I'm still trying to get x by itself. I'll have to eventually get rid of this plus 5, but first of all, I'm going to deal with the squared. And if you have something squared, the whole thing squared, the inverse is the square root. So I'm going to take the square root of both sides. The square root of something squared is the item that's being squared, so x plus 5. And this equals, now whenever you take the square root of both sides of an equation, you need to introduce a plus or minus. That the square root of, say, 16 is 4 and negative 4. So I get plus or minus the square root of 105 divided by 4. Now, tracking up here, if we have x plus 5 equals plus or minus 105 divided by 4, the square root of that, I can then subtract 5 from both sides to get x equals, and I'm going to write the negative 5 first, plus or minus the square root of 105 divided by 4. Now from here you could decide, do you want a decimal answer, something that wouldn't be in inexact form but maybe more useful. Then you'd go ahead and take the negative 5 and add the square root of 105 divided by 4. And then negative 5 minus the square root of 105 divided by 4 to get two different answers. But for right now, we'll just leave it in exact form and call it good. Well, thanks again.